Hey guys, welcome back. I'm going to show you another example on factoring quartic trinomials. Again, as a recap, a quartic trinomial are three terms, and the highest degree there is the exponent of 4. Okay, so we did this by factor by grouping, and we're going to do the same thing. So we want to have 4 terms. In order for us to have 4 terms, we need to break this middle term into the sum of negative 13x squared, but the factors of 40. So we got to look at factors of 40 that would multiply. So we want two numbers that will multiply together that would equal 40, but when you add them together, negative 13, right? So the two numbers that will multiply to positive 40, but when you add them together is negative 13, is going to be negative 8 and negative 5. So I'm going to rewrite my polynomial as x to the 4th power minus 8x squared minus 5x squared plus 40 equals 0. So again, what I did there was I split this middle term into 2 terms, negative 8x squared minus 5x squared, because together they make up negative 13, and when you multiply negative 8 times negative 5, they equal positive 40. Okay, so then once I have my written polynomial, I can now group these two together, and then I can also group these two together. Okay, and that's how I would factor them out by grouping. All right, so we have 8 x to the 4th minus 8x squared. I'm going to factor out an x squared. That's common. And then now I have an x squared minus 8 left. And then negative 5x squared plus 40. I'm going to factor out a negative 5. And then now I have an x squared minus 8 left. And that is equal to 0. And as soon as I have that something in common, I will factor that out too, and then figure out what's left. X squared minus 5. X squared minus 5 times x squared minus 8 equals 0. Now you might be wondering that from our previous example, we had the difference of 2 squares as my first factor and another difference of 2 squares. So it doesn't always come out to be the difference of 2 squares, and especially in this case it's not. But just because that it's not the difference of 2 squares doesn't mean that you can't solve for the x-intercepts. So you can solve for the x-intercepts just by setting the factors equal to 0. So just remember our basic algebraic skills in solving for 0 is I take every factor and I solve it, set it equal to 0. And reversing the PEMDAS, I would add 5 to both sides, so x squared is equal to positive 5. All right, and then furthermore, if x squared is equal to positive 5, then my x's are equal to positive and negative square root of 5, which is a real number. Okay, that is a real number, and that's two of your solutions are positive square root of 5, and the other one's negative square root of 5. All right, so now let's turn to this one. X squared minus 8 equals 0. We're going to reverse the PEMDAS again, so we're going to add 8 to both sides. Now we have an x squared equals 8. And now to solve for x, I need to take the square root. Taking the square root of positive 8 means you're going to have a positive and a negative square root of 8. All right, so as you can see, there goes your 4 solutions. X is equal to, so I'm just going to write down my solution. X is equal to positive square root of 5. X is equal to negative square root of 5. X is equal to positive square root of 8. And x is also equal to negative square root of 8. All right, those are your x-intercepts of this graph. All right, thank you for watching. Have a great day.